Hi everybody, this is our second chapter 5 video. We're still talking about systems of equations, but we're going to learn a second method. In the previous video we talked about using graphing to solve a system of equations, and we said that the solution could be found at the intersection point of those two lines. So we're still trying to find the intersection point, but instead of doing it by graphing, we're going to be doing it algebraically. So substitution is a method of solving systems of equations that involves taking one equation and plugging it in or substituting it inside of the other equation. So we have some steps to solve here. Before we can actually do our substitution step, we have to solve one of our equations for either x or y. Once we know what that variable is equal to, we're going to substitute what it's equivalent to into the other equation and solve for the remaining variable. Now, once we solve for our first variable, we're going to plug or substitute what it's equal to back into one of our original equations and then solve for the variable that's left. All right, so let's look at an example and we can talk about what these steps mean. All right, here's my system. Remember that we're trying to find the intersection point. We're trying to figure out when these two equations are equal. So if my first equation is telling me that y is equal to 4x minus 1, I'm going to take what y is equal to and I'm going to plug it in for the y in my second equation. And we can do this because at this point of intersection, both equations have the same y value. They have the same x value. So if the first equation tells me that y is equal to this, I can plug that in for the y in my second equation. Now, when we do that, we create a new equation. If we make this substitution, I'm going to completely replace y with 4x minus 1. So it becomes 4x minus 1 equal to 2x minus 5. The equation that I'm left with has a single variable. Okay, this takes us back to the beginning of Algebra 1 where we solve basic equations like this. We split it down the middle. We get a variable on one side, so we would subtract 2x from each side. That would leave us with 2x minus 1 equals negative 5. We would add 1 to both sides. We get 2x equals negative 4. And then lastly, we would divide both sides by 2. So we would get x equals negative 2. So we just found algebraically by hand the x value of the intersection point of these two lines. Now, once I know what x is, I still need to find y. But all I need to do is take one of my original equations and plug in my value that I just found for x. So let's use our bottom equation. Y equals 2, and then I'm going to plug in negative 2 for x minus 5. And then we're just using our order of operations to simplify. It would be negative 4 minus 5, which is negative 9. So we have x, we have y. The solution would be negative 2, negative 9. And keep in mind, again, this is the intersection point. If we would graph these two original equations, we would find their intersection point at negative 2, negative 9. So let's look at another example here. Okay, in this equation, notice that not both of the equations are solved for y like the previous one. Only the top equation is solved for y. So that's fine. We don't need to solve the bottom equation for y. What we need to do is we need to take what y is equal to in this top equation and substitute it in for y in the second equation. Now when we do that, it's going to look a little different. We still have our 2x. We have our plus 3 times, and then instead of y, we're substituting in 6x. And that's equal to negative 20. Okay, from here we're solving. Well, 3 times 6x would make an 18x. And if I have 2x plus 18x, that makes 20x. At this point, I would just divide both sides by 20, and we would find that x is equal to negative 1. Once I have the x value, we're going to go back and plug that x value into one of our original equations. Again, it doesn't matter which one, but it's going to be a lot easier to plug it into the top equation because it's already solved for y. We substitute in negative 1. We find y is equal to negative 6. So our solution to the system would be negative 1, negative 6. Now, each of our equations has been, solved for y. One of the equations has been solved for y, and we make that substitution for y. But it doesn't necessarily have to be y. Okay, in this example, we have x that's solved for, and we know that x is equal to 4y plus 7. So this time we're going to make a substitution for x. So when we do this, we would get a new equation. It would be 2 times 4y plus 7 minus 6y equals 12. And we need to solve. So we would distribute the 2. We would combine our like terms. We would get y by itself, so we would subtract 14 from both sides, and then divide by 2. So this time we found y first. So to find x, we're going to plug y in to one of our original equations and solve for x. Again, it doesn't matter which one we plug it into, but if we're solving for x, it's going to be easier to use the top equation. X is equal to 4 times y, which we just found was negative 1. And then we add 7. So we would get negative 4 plus 7, which we know is positive 3. Now, just because we solve for y first doesn't mean that goes first in our ordered pair. Ordered pairs always have the x value followed by the y value. And that's our solution. So let's take a look at an example here where neither of our equations have been solved for a variable. Okay? The first step of substitution is to make sure we have an equation that's solved for either x or y. Well, we don't have that anymore. So we need to do that as a first step. We need to solve one of these equations for either x or y. And here's my hint to you. Always solve for the variable that doesn't have a number in front. Now, yes, there's really a 1 here, but when it's just 1, we don't have to actually write it. Solving for the equation, or I'm sorry, solving for the variable that doesn't have a number written in front is going to help you avoid creating fractions when you solve for that variable. If I want to solve my top equation for y, it's as simple as subtracting 2x from both sides. I would get y equals negative 2x minus 2. Okay, now it looks like our previous problems. I know what y is equal to, so I'm going to take that and I'm going to plug it in or substitute it for y. So now we have 5x plus 3 times negative 2x minus 2 equal to negative 8. We're solving. So we distribute first. We have 5x minus 6x minus 6 equals negative 8. Let's combine our like terms to get negative x minus 6 equals negative 8. Add 6 to both sides. Divide by negative 1. So we find that x is equal to positive 2. So we find y by taking that x value and plugging it back in. Now, it's going to be easiest to plug it into my rearranged top equation because it's already solved for y. So we would get y equals negative 2 times 2 minus 2, which gives us negative 6. So our solution here is 2, negative 6. So here's another example where neither one of our equations is solved for a variable. So again, the hint is solve for the variable that does not have a number written in front of it. In this case, it's the y in the bottom equation. So we're going to solve this equation for y. We're going to subtract 2x from both sides, and we get y equals negative 2x plus 9. So now we can make a substitution. We know y is equal to this, so we're going to plug it in for the y in the first equation. So that gives us a new equation, 2x minus 3 times negative 2x plus 9 equal to negative 11. So we're solving again. We need to distribute. We get 2x plus 6x minus 27. that's all equal to negative 11 here. We can combine like terms. We get 8x minus 27 equals negative 11. And then we add 27 to both sides. And then we divide by 2. Or I'm sorry, divide by 8, and we get 2. So we know x, we need to find y. So again, I'm going to plug it into my rearranged top equation because it's already solved for y. Y equals negative 2 times 2 plus 9. So we get negative 4 plus 9, which is 5. And there's our solution. All right, I hope this video was helpful. Please ask questions, pause, rewind, rewatch, and have a great day.